Hello. Today we are going to see the topic on cellular manufacturing from the subject Computer-Aided Design and Manufacturing. Myself, K. Sadish, Assistant Professor Mechanical from Sri Ishwar College of Engineering, Coimbatore. So, the term cellular manufacturing, it is the concept of group technology in which in manufacturing industry having different number of manufacturing systems. These each manufacturing systems are going to convert in terms of a cells, that is a manufacturing cells. So this manufacturing cell refers to, it is a cluster of machines or process located in close proximity and dedicated to the manufacturing of a family of parts. So in order to develop this manufacturing cell, it is used for the purpose of to develop a family of parts. So why this cellular manufacturing is required? So it is required to reduce setup times, to reduce flow times, to reduce inventories, and to reduce this manufacturing lead time. So once in order to develop the machine cell, it can be done by means of the cell formation approach. The cell formation approach can be done by means of machine component group analysis. So this machine component group analysis is based on the production flow analysis, that is PFA, production flow analysis. So this production flow analysis involves 4 different steps. The first step is machine classifications, in which the machines are classified on the basis of operations that can be performed on them. And step number 2, checking part list and production load informations. Step 3, factory flow analysis. And step 4, machine component group analysis. So let's look into the example. Let us consider there are 4 different machines and having 6 different components. These components are machined under these 4 machines. As per this matrix, let's say this component number 1 is machined under machine 3 and with machine 4. Similarly, based upon the root sheets, this matrix form is getting filled. Once we did this group analysis, that is the machine component group analysis, this entire matrix is converted into a manufacturing cell. So this is one kind of manufacturing cell and this is another kind of manufacturing cell where the group analysis is done. So this group analysis can be done by means of an algorithm called as rank order clustering. This rank order clustering is one kind of algorithm to do a manufacturing cell. So this rank order clustering having 4 different steps. Step number 1, giving the binary weight for the respective rows and columns. Step number 2, rank the rows in order of decreasing decimal weight values. Step number 3, repeating the steps, that is giving the binary weight and rank the rows. Step number 4, continue preceding steps until there is no change in the position of each element in the row and column. So let's look at an example. So here there are 10 different components. These 10 different components are machined under various machines, that is from machine 1 to machine 5. Here there are 5 machines and 10 different components. So these informations are gathered based upon the root sheet. So as per the steps, the first step is giving the binary weight. So now here there are having 10 different components and 5 machines. So these components are going to give in terms of a binary weight, that is raising this binary weight from 2 power 0 to 2 power 9. Since because having 10 different components, giving the binary weight from 2 power 0 to 2 power 9 and doing the summation with respective in terms of row wise, that is from 1 into 2 power 9 plus 1 into 2 power 8 plus 1 into 2 power 7 and so on. So adding up these summations in terms by binary weight, so the decimal equivalent is 1007. So this binary weight is done for respective rows. So this is the respective values. So let's take the maximum value. Then here the maximum value is 1020. That is machine number 5, which holds the rank number 1 and giving the rank values for respective maximum values. That is the machine number 5 is rank number 1 and machine number 1 is rank number 2 and so on. So once the rank is given to the respective machines, it is reshuffled. The entire row is getting reshuffled. Once the row binary weight is given here. Then the next step is giving the binary weight for the column base, for which the column number 1 is giving the binary weight of 2 power 4 and column number 2 is giving the binary weight of 2 power 3 and so on, and the summation is done based upon the column base. Once the summation is done, the respective decimal equivalent is 28. Likewise, calculate the respective decimal equivalent for all the columns and give the maximum rank value, that is the maximum decimal equivalent having the rank number 1 and giving the respective ranks for the respective columns. So once the ranks are given for the respective columns, it is getting reshuffled here. Here the component 1 having the maximum value, next to that the component 5 is having the maximum value. So it is the second column is reshuffled with component number 5. So once we get to the binary weight giving the row weights and column weights, the machine cells are rearranged and form a machine cell. So this is one kind of method in order to do for machine component analysis. So this method is doing for the purpose of arranging the machine components in a manufacturing cell. Next thing. So once the machine component analysis is done, after the formation of machine component analysis, the next thing is arranging machines in a GT cell. So once the manufacturing cell is formed, in that particular manufacturing cell, we are going to rearrange the machines by means of the method called as Hollier method. So this Hollier method having 5 different steps. The first step is to develop from to chart from the part routing data, and second step is determining the from and to sums for each machines. Third is assigning machines to the cell based on minimum from or to sums, and fourth one is reformat the from to chart and repeating the steps until the machines are rearranged. So let's take it and clear by seeing this example. So this is data taken by a root sheet. From this root sheet, we are going to form a matrix, that is from to chart. So for an example, it is a machine number 1. Once the machine number 1, it is from machine number 1, 5 parts are transferred to machine number 2. Here from machine number 2, 30 parts are transferred to machine number 1 and 15 parts are transferred to machine number 4. So this is the data which are taken from this root sheet, that is it is a data given here. So once the matrix is formed here, we are going to do the from to summations. So for the first iteration is so it is from sums. So doing the from sums for respective rows. So from machine 1, the summation is about 30 and the summation is done for respective from row wise, and for the column wise the two sum is done. So as per these steps here, the machines are going to be rearranged. So let's look at the step number 3. If the minimum value is a 2 sum, then the machine stays at the beginning of sequence. So now, based upon this chart, the minimum value here is on the 2 sum is 0. So therefore, this machine number 3 stands first on the machine sequences. So once the sequence is done, they enter the respective row and column is getting removed. After that, again doing the summation for the respective from column and to sums. So once again this from sum and to sum is done, check with the sums that having the minimum 2 sums. So in these second iterations, the minimum 2 sum is 5 for machine number 2. So again, the second sequence is after the first machine is arranged here is machine number 3 and the second machine is arranged here is machine number 2, since because it is having the minimum value. And next to that, again we are going to do the from and to analysis for the remaining machines, that is 1 and 4. So in which having the minimum value is 10, at the same time the from sum is having the minimum value is 10. So here we are having this tiebreaker. So again we are going back to step. So if the tiebreaker is happened here, if a tiebreaker occurs between minimum sums or minimum from sums, then the machine with the minimum from 2 ratio is selected. So once there is a tiebreaker between the minimum value of from sums and 2 sums, we are going to make a from by 2 ratio. So here we are taking this from by 2 ratio, since because the tiebreaker is happened between machine number 1 and machine number 4. So once do with the from and 2 sums, the machine number 1 having the maximum value of from by 2 ratio and machine number 4 having the maximum value of from by 2 ratio. So minimum value of from by 2 ratio. So therefore the sequence of machine is 3, 2, 1, 4. The first minimum value of 2 sum is machine number 3 and the second value of 2 sum is machine number 2, and based upon the tiebreaker happened between 1 and 4, we have did this from by 2 ratio, in which the machine number 1 having the maximum value of 0.60 and therefore it stands third in a sequence, and the last one is machine number 4. So that this is the Holier method in order to making into a machine sequence. So once the machine sequence is done, this is the percentage of, this is one kind of flow analysis in which the machines after the sequence is done in terms of 3, 2, 1, 4. This flow diagram is drawn by means of this chart, in which this from machine number 3 to machine number 1, 10 parts are getting transferred, and similarly from machine number 2 to machine number 4, 15 parts are getting transferred, and similarly from machine 3 to 2, 40, and similarly from machine number 1 to 2 having the 5 parts are getting back transferred. So let's look at a diagram here. So here there are total number of in sequence moves, that is it is a directly sequence move, that is from 3 to 2, 2 to 1 and 1 to 4. These are called as an in sequence moves, in which the total summation is 40 plus 30 plus 25. Therefore the 90 moves are here for in sequence moves, and the total number of moves is the total number of in sequence moves plus all the respective moves including these back moves. So 95 plus 10 plus 15 plus 5 plus 10. So therefore the total number of moves is 135 moves. So now taking into the ratio of the in sequence moves and total number of moves, the percentage of in sequence moves is 70%, whereas the percentage of backtracking moves is where here the backtracking moves happened between machine number 4 to 1 and machine number 1 to 2. That is the total backtracking moves is number 15 and the total number of moves is 135. So therefore the percentage of backtracking moves is 11.1%. In an industry, they often look at on these backtracking moves. If the backtracking move is very minimal, it is the Holier method is very effective. So thank you. So let we look at on by giving some other topic on next session. Thank you.